I'm going to introduce you to our very first agent we ever built, which is Media Mix Mary. All right. So I'm going to go to the settings of Media Mix Mary. And the first thing I'm going to start with is the data. So here's a preview of the data that we were able to build in NinjaCat of aggregate spend across all channels, both digital as well as linear, like TV and radio, right? So by date, the revenue, which is the variable we're trying to drive, the spend for each channel, both digital as well as linear, like I said, radio, TV. And the cool thing about media mix models is they can have other variables. Was it raining? Was COVID going on? Was our competitor running a campaign? So that's the data set that we are tying Media Mix Mary to. Our agents can be tied to one or multiple data sets. So we're not restricting, right? So if they need to look across 10 different data sets, for example, to get to the answer, you could provide access to all of those different data sets or the pre-made views. Once they have access to the data, they just need a prompt, right? What is the task that you're being asked to do in a specialist fashion, consistently and reliably every single time? In the case of this, we are building Media Mix Mary, that is an expert data scientist with a specialty in media mix modeling. So if we look at the prompt over here, right, what we're saying is this is your core identity, budget allocation, ROI. Here are some operating principles around like asking clarifying questions, only providing factual data. If you can't answer something, tell me you can't answer it. The communication style, and then some of the technical things required to make Mary work, such as when you need to access data, which tools are you going to use to go find that data, right? So that's being defined in the prompt here, as well as some steps that we want Mary to take every time. Agents or AI will always try to please you, and they'll always come up with a plan. It just might not be the same plan every time. So you might want some consistencies. Here, we're being specific and saying, step 1, always do a lagged effect analysis. Step 2, then do a media mix model, build the model, rate the model. Step 3, you'll see in here, then get into some what if analysis with the user. But a pretty small prompt for what you're about to see here, for what it can do. But that concept of like basic steps to follow, but you don't have to tell it how to do those steps, right? And then a prompt, the data plus the prompt plus the tools required to achieve that task. In this case, you're going to see that this agent code interpreter to do all the data science Python type work, as well as a bunch of built-in tools that are just native to NinjaCat's data-driven agents to go find the data, write the natural SQL, and do that RAG injection of that data in at the right spots here. So let me show you what this looks like. All right. So given that configuration, pointed to the right data with a prompt and having access to the right tools, user experience here, user come in and say, go, include 0 days lagged effect, and be as detailed about your plans as possible. So this is the plan that Mary wants to execute. Go find the data, then do a lagged effect analysis, get confirmation, do some media mix modeling, do some diminishing returns, and then come up with some recommendations. So it came up with a plan, and then Mary needs to start acting on that plan. So the first tool she calls is that query executor that goes into the NinjaCat data cloud, finds the data sets, writes the query to get the raw data to be injected into the next step of this flow here, which is the lagged effect analysis. Now, at that point, it's calling in the next tool, which is the code interpreter / Python tool. So it's taking that data and behind the scenes to overcome any like context window limitations, passing that raw data into our code interpreter. And with all of our tools, we try not to overwhelm you with them, but you always need to have visibility into what is the agent doing, right? Making sure it's not hallucinating, making sure there wasn't ambiguity to make sure it was following the proper steps. So I can click on the 4 scripts executed and see what is that sub-agent, the code interpreter coming in to do. And then it's summarizing its findings, in this case, the lagged effect analysis, being produced in both chart as well as tabular form. So if you haven't done a lagged effect analysis, right, this is just basically saying when you spend money on different channels, I spend money today on a bottom of funnel search campaign, I should see the impact today. If I'm spending money on radio or TV or billboard, I might not see that from the day I spend to the day I see the impact might, be a lag of X number of days. So that's the step that this is doing, all the regression to figure that and presenting the user. That's an important input into many media mix models. So the user just says proceed or says, no, actually change this one to be 0 days. Well, and then Mary gets going, right? Knows the next job to build the model, rate the model. You can see all the steps that she's taking to do that. And then the output, the rated model, in this case, 89.3, which is quite good. And then from there, it's spitting out the model. So the purpose of media mix model is, if you haven't done one, is to get to something that looks like this, the coefficients, right? The coefficients here is basically saying, based on all those statistics that we did here, what the data is saying is that for every dollar that we spend on radio ads, we're killing it. We're making $8.57, right? However, for every dollar that we're spending on these specific display ad campaigns, we're losing 3 cents. So now we have that context, right? These coefficients for every dollar we spend, how much are we making or losing? And then the next step is it is told to do a diminishing returns analysis per channel, all right? Because you can't just do budget shifts and expect, a linear return. So it's automatically going. The user only said, go, proceed at this point. And then part of its task was to then come up with a budget simulation, right? So at this point, you could see the simulations that are being done. And the final output is, if this is for you as a brand, or if you're an agency working on behalf of a brand, the output is saying, if we increase budget by 20% for these high-performing, high-coefficient channels and decrease by 20% for these low-performing, low-coefficient channels, we could see a lift of nearly $500,000. And what's really cool is we can keep asking clarifying questions at this point. What if it was 30%, for example? So that was, an aha moment. It was like, whoa, right? If we can build that, then what can't we build?